Hello guys, today we are going to talk about final keyword. So I tell you what is it exactly, how and when use it, and I tell you about a few advantages of it. Before I tell you what is it and how does it work, you have to be aware of context on which the final keyword is used. Okay, so generally we've got three. The level of class is the first one. Second is the level of methods. And the last one is the level of variables. So it's crucial to understand that today we are going to focus only on a variables level. Okay, because for other levels, the final keyword works slightly different, and we need to understand those contexts. Okay, but for now, we don't know what is it a class, we don't know what is a method, we don't know what is it a constructor and some other things. So when we get familiar with all of those concepts, I return to final keyword and tell you more, and I extend the knowledge about the final keyword. So when we declare a variable as a final, that means once initialized variable cannot change or modify its value. It makes it a constant. So we cannot reassign or rewrite its value, or even it cannot be done while program is running. Okay, so that's how it works. Okay, so when and why can we use it? Simply, when we've got a variable that we don't want to change, or we know it won't change in the future, like number of days in a week. It's always 7, right? So it can be a final. And the second question, why? The final keyword comes with two main advantages. First one is a performance. Sometimes, not always, a compiler can optimize the code to be more efficient. And the second is a security context. It prevents a code from modifying. Let's say when we want to protect a sensitive data. Okay, if we know all of this, let's see how to create a final variable and check if it works as I said. To create, we need a final keyword, of course, and simple variable. The crucial thing here is that we have to initialize that variable. It's something that must be done. We can do this in two ways: in constructor, in static blocks, and when it is declared. Today I'm not going to show you how to do this by constructor or static blocks. I'll show you this later when you get familiar with concepts of constructors, classes, static blocks, and few other things. So let's focus on the most common way and do this as standard variable with the final keyword on the beginning. Okay, so we've got the final keyword, and let's say integer type, name unmodifiable, value 4, let's say. Okay, so we've just created the final variable that cannot be changed. Let's create another variable, but this time the standard one, and check the difference between those two to see how it works exactly. So let's say integer, this time modifiable, value 5, and let's print them out. Okay, awesome. Let's try to change the value of unmodifiable variable. For example, unmodifiable, let's try to assign number 9. Okay, and you see we've got an error. When we hover on it, there's a hint. I cannot assign a value to final variable unmodifiable. So that's true. We cannot change that variable because it's final, means constant. So let's comment this. Change the second variable, say here, maybe 15, okay, and print them again. So as you see, final constant variables cannot be changed, but standard ones we can change as we will. Okay, next thing. Let's say we've got array context. So we've got int array, new int, let's say 4. Okay, because you're already familiar with arrays, it's good for you to understand how the final keyword works for them. First of all, one thing I didn't mention in the lesson about arrays is that arrays are treated as complex types, or we can call them as reference types as well. Those two names are interchangeable, but what does it mean? The reference, the name for complex types, like this name of array, is nothing more than an address for that structure in memory. So, by the name of an array, we refer to the place in memory to read the values. And that's all for now. Please notice this description is a bit simplified, but enough to understand the final keyword context for arrays. On the other hand, I don't want to dive into details that can be a little bit tricky at the beginning of your journey with programming, but the right time for learning those things will come. Okay, so as for standard variable, when we add the final keyword, we cannot change the value. But for a complex type structure like an array, when we add the final keyword, we can still change its values as we will, but we cannot change the reference, the address to that array. Let's see. We've got the array here. I put the final keyword here on the beginning. Okay, and now I'm going to set the cell under index 0. So let's say ints index 0 and number 5, let's say. Okay, I don't have any errors. So now I decided to override the same cell. So I duplicate this and put it here, maybe 10. Okay, there's no problem either. So we can do that as many times as we want. But now the power of final keyword for the arrays. Let's try to change the reference for that array by new keyword. Something like this, new int, let's say 6. Okay. The new keyword simply finds a new free place in our computer's memory and allocates our structure there. But as you see, we've got an error here. We cannot do this for the final array. But when we remove the final keywords, let's say here, the operation is okay now. So this is how the final keyword works for variables and reference types. Now, the last thing about constants, the naming convention. There's a bunch of schools and eternal debate over which naming convention adapt for constants. But in reality, in authentic projects, it always depends on what was adopted by team. So the standard is that constants should be uppercased with an underscore between words if the name consists of more than one word. Like this. On one word, ints, okay? But for more than one word, final string, let's say 2 words. Okay, we need underscore. And here, of course, final, like this. But there are different contexts in which the variables can exist. And depending on certain contexts, the constants can be declared in distinct way. There are following contexts for variables: instance variables, local variables, class variables, and parameters. I'm not going to dig into them right now because it's too early for that, but as I mentioned, the conventions highly depends on what was adapted in a particular project. So for now, anchor in your mind that constants can be declared in uppercase, which is actually a good practice because they can be more readable, for instance. And don't be surprised when you see something like this in someone else's code. But for now, for our purpose, in our small lessons, we are still around local contexts. So that's why we are going to adapt a standard camel case convention for constants. But it will change when we gain a little more knowledge. So that's all, I guess, in this lesson.